Good afternoon. I'm here from HSBcad. We're participating here in the hackathon with two other guys. That's finding my mouse here. No, that's not working. With Bill and Jill. We are a company that are focused on offsite of timber construction, basically. So we're about 40 people currently. We have offices spread a little bit around the world, one in Japan, one in Germany, in the UK, in Holland as well. So we are, if you look to the industry that we're in, as I said, prefabrication, but in that wood prefabrication industry, there's a couple of, let's say, specific parts of the industry. One is post and beam. So we have a plugin in ACA and a plugin in Revit. We have also external applications. Basically, any platform can do. But our plugin in ACA and in Revit is able to, if you use that, you're able to specify all these different connections, typical German, typical Japanese connections, and then finally bring these to the machines. So that's the focus. So we're basically taking off where the architect started. So we're focusing on production prefabrication. So post and beam is an important one and a more complicated one. The cash cow, I would say, is stick framing. So the more complicated stick framing where prefabricated elements, wall elements, roof elements, and floor elements are prefabricated, pre-assembled in the factory, and then transported to site. Another very important sub-industry is CLT. CLT or its variants. You may be familiar with it. CLT is an acronym for cross-laminated timber. So these basically parts or low-quality wood that are glued together to form rather thick panels of let's say 20 centimeter, 30 centimeter panels, thick, 12 meters long, 4 meters wide, of which then floor elements and wall elements are cut out. It's let's say, a replacement for concrete. It's getting rather popular. And then a little bit of more smaller industry segments like curved timber and structurally insulated panels and log building. Now, I'm going to show a couple of images of projects that customers of us have done with our software. So one of them is the Pyramidekegel in Wörthersee, in the south of Germany and Austria, basically. So the top is actually done as curved timber. It was done by one customer, and then the bottom part was done by another customer, Haslacher, while the top part was done by Glöckel, I think. So you can, it's not only simple geometry, it might be more complicated geometry. These curved timbers, they are curved in one dimension. That is, for prefabrication, it's kind of a given. It's not a requirement, but if you have a fabrication table, obviously, it's normal. So this is another project that was done by our French customers. And so here, the particularities of this project is everything needed to be really cut precisely because the construction time was only 3 months in the summer, where the Mont Blanc or that part of the Mont Blanc was accessible. All pieces need to be taken up by helicopter, so that means the pieces had to definitely fit. No fiddling around allowed, basically. There's another a little bit bigger project here, an airport in the Philippines. So you can see it's kind of special projects, but most of the time HSBcad customers will be doing stick framing. So this is what the bigger part of the market of prefabrication in wood construction is all about. It is nailing, gluing, frames, filling insulation, adding layers of sheeting, and then basically delivering them on site. Prefabrication is really, or the main part of prefabrication is about this. And that's where we're focusing. So in the drawing, you will have to add your nail lines, your milling lines. Basically, from that source, CNC has to be generated. These CNC files will contain nail spacings, will contain no nail areas, milling lines. They will contain possibly from the model instructions on particular things to construct, to verify, to validate the construction and so on. Here you can also see in the model there's these lifting devices, lifting anchors. They were placed in the model such that when you lift it with a crane with a single point, that the piece would still be in equilibrium, basically. So the location of these parts needs to be milled on the machine, prefabricated as well. Obviously, it cannot be at a location where there is a stud or something. So there's logic that has to happen during the design process to make it deliverable on site in the truck. You can see here in this on this slide, there's actually a truck waiting in the back with a lot of these devices. So such a house, this is company Lux, I think. They will erect the building in 3 days. So it's basically windows and everything are pre-mounted. Electricity, plumbing is all present. This is really what our customers, most of the customers, or a big chunk of our customers work with. So as I said, in the drawing you have to specify lots of things. Obviously millings and operations like that. Cutouts, obviously, you see these dotted lines here, they are nail lines with nail spacings. They are generated either automatically, wherever possible. Then there's possibly some validations that run, or manual adjustments. And on top of that, the validations of these manual operations. We have a plugin in ACA, a plugin in Revit, as I said. This is an image of some toolings of our Revit plugin to add all these different tools. This is a 1-minute video, so it's about this Revit plugin, and in particular our Golden Nugget participation. So the Golden Nugget is the model that is distributed with Revit in the current version, in the DACH content. Maybe I can reduce the sound a little bit. A lot better. So in our HSB Timber on Revit, we have these different sets of tools. We can generate automatically, partly automatically, shop drawings of these pieces. It can either be done externally as well, but finally we will drive the CNC machines from that information model. And it's part of the Golden Nugget project, which is part of the DACH content, which you can download with Revit. Basically, from these plugins, from that CNC, we generate all the CNC. From these plugins in ACA and Revit, we generate CNC files for lots of different machines. But we have this layer in between. And that layer in between, that's we have an independent object model there, CAD independent object model, that allows us to interface with whatever input, basically. So there could be cloud as well. If you have a configurator for your garden sheds, no problem. That can be handled as well. We do have, because these tools in Revit, they're just based on normal void cutting, like we have in Revit. You can define voids and void families that can cut other pieces. So we actually simulate the operations that are done by the CNC machine. So these void cutters, they actually can be driven by dynamo. Now, every company is has its specifics. Every company in construction has their own way. They work with their own materials, their own details, their own secret way of constructing things. So that means that the shop drawings that need to be generated are always specific to that company. Therefore, we have come up with platforms or tool sets that allow to generate really customized dimensioning, customized shop drawings, basically. As I mentioned before, there is this validation. Validation is an important thing and becoming more and more important. On the CAD platform, of course, you want to do things automatically as far as possible. But there's always the special interactions with maybe neighboring buildings or existing buildings. There's maybe odd things, late minute changes. So your automation in your design or in your detailing might need manual interaction. And after that, after doing these manual interactions, you want to run your validation tests. Validations could be, is there a nail line on every edge of a sheeting board where there is a stud behind? Things like that. So these validations are obviously custom. We are driving, so yesterday at one of the keynote speakers there was Katerra mentioned. Katerra is one of the bigger innovators in North America, in the US. They have a factory in Phoenix, and HSBcad is actually driving or automating that production facility. So besides the CNC generation as such, we do have what we call our automation framework. Our automation is focusing on, let me go back to slides here, on driving a network of these machines. So you have a couple of servers that take care of sequencing, planning, of course, capturing data of quality control and so on. So here in the background you see a lot of manual stations in that factory. There's more manual than machining. But even these manual operations, these manual workstations, there you want your, you want to be sure that these lesser schooled labor is able to perform the task properly. So that means that you have the possibility to introduce clients, to introduce devices, printers, and so on, to just automate and digitalize your production facility. So, I've mentioned there's a little bit the key part in HSBcad, our Revit plugin, our ACA plugin, our production management system. Production management, for instance, being used at Katerra, at Lendlease in Australia, but also at a lot of different companies. Now, production is not only happening on site. There is happening a lot, or I mean, off-site. There's also a lot of interaction with on-site. On-site, the erection where the building gets built, actually, there's issues, there's feedback, there's basically a collaboration system is required, and for that we use what we call HSB Share. It's I would say a Forge tool that allows collaboration, but also aligns the workflow, aligns the user processes for that prefabricator. And to close my presentation of today, I would like to show a small video of a side project we've done with HoloLens. So we built a small HoloLens application 2 years ago to allow to visualize your fabrication things. But one of our customers, a Swedish company called Hus, their IT partner developed on top of that the following. So you see here what that HoloLens guy is seeing. You see here's on the left a panel or a machine. On the right side here you see a big panel, typically to be constructed in the factory. But on top of that you see these lines, the red line, the gray lines, and they represent tubing that need to be added here on this table. So obviously it's not present yet, and it will need to be drilled. In this case, it's a manual table, so the production process is not set up like we're going to pre-drill these holes and then fabricate or assemble the wall element. No, we're going to assemble it without knowing which piece is there and then drill these different parts on the table. Now, if you want to find out where all these things are, AR is an opportunity. AR is a possibility. But using the HoloLens here, okay, of course you have to locate your panel, your virtual panel on the real panel. So as you approach the end, you see the correction of the HoloLens kicking in. But you see, it's still quite off. Although the HoloLens is rather accurate and very stable image and so on, it's a tricky thing to position that virtual model right there where you want where you have the physical model. But then again, for drilling, for positioning these tubes, that would be far accurate enough to do that job. But it's actually an application where that AR, augmented reality, makes sense. So it's kind of something I wanted to share with you. So that's about everything that I wanted to bring to you today. Philip?
Perfect. Thank you very much, Chris. Thank you for your time. So are there any questions you would have for Chris around timber construction? And is there anything? Keen?
So, which do you sell more of, the Revit app or the ACA app?
ACA is sold more, definitely. Yeah. But our Revit application is used a lot. Okay. There's a free plugin available on Revit Download, on Revit App Store, whatever. And it's used also to capture the model and then export it into the ACA world as well. So it not only contains the possibility to draw the tools and everything, but to also to export and import our HSBcad specific information. Stick framing and so on is one thing without the more complicated tools. But there's also this communication in the CLT world, where a lot of design, a lot of projects and so on are done in a Revit environment, where Revit is actually a perfect candidate. But as I mentioned, our software is also used in CLT production. CLT production is actually, you need software to nest, to add all these machining and so on. So Revit is not the perfect platform. An ACA world is perfect in that case. So to drive that communication, our Revit plugin can also be used. So in that case, it's used a lot.